Good morning. Here we are talking about chapter 11. And believe it or not, here we are at 11:5, and it's the end of the chapter. This is probably one of the shortest chapters in our text. So we're going to be talking about areas of similar figures and no real vocabulary, but we do have a concept that we need to really make sure we understand. So here we have two similar trapezoids, and what we know is that if these two figures are similar, and we remember what similar figures are. They're, in the layperson's term, they're just like an enlargement or a reduction, keeping exactly the same shape and same angles. We know that that really means that in our geometric sense, we mean that the sides are proportional, the angles are exactly the same. And so if we have a situation where we have similar figures, what we know is that the area of one figure to the area of the other figure is the square of the ratio of the side lengths of the figures. Yeah, that's what I want to say. All right, so that's what's happening here in this theorem 11.1, and let's see if we can use that theorem, hold on to it in our mind, and use that theorem for this next problem. So in example 1, it says that triangle JKL is similar to triangle PQR. We've got the triangles here, and the area of JKL is 30 inches 30 square inches. Find the area of PQR. So let's say JKL is 30 square inches. Use a finer pen. 30 inches squared. And we know that these two are proportional to one another. We also know that if we look at the orientation of them, we know that the linear relationship is going to be 12 to 15. That's their ratio. And I'm going to reduce that ratio just so it's easier for me to deal with. And I know that 3 divides evenly into each. So the ratio of the sides would be 3 to 5. I hope that made sense. This is the same thing. And so what we saw from this theorem back here is that the areas are at a ratio of the square of the linear ratio of the sides. So I'm going to square this. Remembering this 3 or this 12 comes from JKL, I'm going to put the area of JKL up at the top and know that I'm looking for the area of the bottom triangle, or PQR. And so now that I have that together, I've got 9 is to 25 as 30 is to x. You guys remember how to solve proportions. We do cross multiplication. So we end up with 30 times 25, which is 750, 75 with a 0 at the end. And then 9 times x, which is 9x. I'm going to divide both sides by 9. And when I do that, 9 goes into 75 8 times with the remainder of 3. 9 goes into 30 3 times with the remainder of 3. It's going to be like 83.333 repeating, and then that's what x is going to be. So that's what my area is going to be. Kind of cool, right? So that's the idea that we're going to exploit in this section. Inches squared, yeah, inches squared. All right, so let's look at this next one, example 2. Again, we have two proportional figures, or two figures with sides are proportional, they're similar. And the area of ABCD, that's this larger one, is 150 square meters. And then the area of FGH is 54 meters squared. If these two triangles are similar, find the scale factor. Okay, so that's the word I wasn't saying right. I said the ratio of the sides, the linear ratio. It's the scale factor. Find the scale factor of these two parallelograms and find the value of x. Okay, so scale factor and x needs to happen. So what I do know is that 54 is to 150 as the scale factor is squared. And the scale factor would be like x to 10, right? And it would be squared. So I need to figure out what x is. So I'm going to take the square root of both sides. And I get x over 10. And then now I'm going to solve for x. And I'm just going to pull out a calculator if I have to. Multiply both sides by 10. And I get 10 times the square root of 54 over 150. And take a calculator break. And magically, it came out to 6. Now I'm intrigued because I'm like, how did that come out so nice? So I'm going to check this out for myself. So I'm looking at the square root of 54 and I'm thinking, did I have to put this in the calculator? Maybe I can reduce it and see something that's going on. So when I look at the numerator and denominator, I realize I can actually divide both by 6. So this really becomes the square root of 9 in the numerator. And when I divide 150 by 6, I end up with 25. Ooh, very nicely played. So then I get 3 over 5. I did not see that. Did you see how lazy I was and I went for the calculator first? Sad, sad woman. Okay, so I have 10 times 3/5, which is equal to 6. I just had to go back and do it, right? You wanted me to do that. All right, so I get 6 as the value of x, and since 6 is the value of x, the scale factor, which is what they asked me for in the beginning, is going to be half of that, 3 over 5, which came up last time, which is here. Okay, so which is 3 over 5. Does that kind of make sense, everybody? I hope so. And with that, I'm going to let this be the truly shortest video we've ever had. And I'm going to let it go because I think you have the concepts and we can talk about it a little bit more when we get together. Take care, guys. Have a good one. Bye-bye.